All right, so now that we've talked a bit about developing before birth, let's talk about infant development and where the person's development is at when they're born and how these structures are going to continue after birth. So, I want to point out one interesting thing about human beings relative to other species that human beings, compared to other animals, are much less developed when they're born. And I think this can be kind of obvious when you think about, the fact that like gazelles and giraffes and creatures like that can walk moments after being born. They have more awareness of their surroundings. They have more physical abilities, and human beings are really extremely helpless when they're born, right? They are extraordinarily vulnerable, and that's in part because we have so much brain development left to do when we're born. So if you even compare our brain development to our closest animal relatives, chimpanzees, a newborn human's brain is only about 25% of its ultimate eventual weight when it's born. So that brain is only a quarter of the size that it's going to be when that newborn becomes an adult. A newborn chimpanzee's brain is over half the size that it's going to be already. It's 60% of the way there to its full size. And other creatures, smaller creatures, are even much closer than that. Its brain is sometimes going to be almost its end size, basically. So there's tons and tons of development going on after a human is born compared to other creatures because we are so cognitively complex. Just physically, human beings, when they're born, tend to be around 7 pounds or 20 inches long. But that weight, just like the brain is going to develop a lot in the next several years, that weight over the next 2 years is going to generally at least quadruple. So by the time a kid is 2 years old, they're going to be closing in on 30 pounds most of the time. Obviously, there's a lot of individual level variation here, but these are, generalities. The child around 2 years old is also going to be around half of its average height, so usually somewhere between 2.5 and a little over 3 feet. So a lot of this development and growth is happening very, very quickly relative to someone's lifespan over the next couple of years. The brain also is going to, by the time someone is two, be about 75% of its ultimate eventual weight. But it's important to remember that the brain of a 2-year-old, while it has the mass that it will, or 3/4 of the eventual mass that it will have, it's not even close to the eventual complexity that it's going to have. Because all throughout childhood and even into your teens and early 20s, the human brain has an enormous level of plasticity and development that's continuing to go on. So in the first 2 years, there are tons and tons of changes as well over the what we might kind of euphemistically call your neural circuitry, where you have the neurons that we've talked about. Remember, the dendrites are kind of the receiving message tree-like structures. The axons are the message senders that are hooking on to dendrites on the next neurons. But dendrites are sprouting. They're sprouting more of those branch-like, tree-like structures. They're making connections to new, to other neurons and creating new synapses based on learning and activity. And remember, when you become, when you're closer to adulthood, some of your neurons might have 10,000 connections to other neurons. So these things are happening very quickly over the first 2 years as well. And it's not just that things are growing and changing in that sort of additive way, but neurons that are not being used are also starting to die off, even in this early period. So even children are losing brain cells because if they're not being used, then they're taking up valuable space and energy and resources, and your brain kind of kicks them to the curb. So the plasticity that's going on early in life is unbelievably important. Your genes tell your brain some things about how it is supposed to develop and grow, but the real driver of those connections that you're making are the experiences that you are having as a child, the things you're seeing, the things you're hearing, what people are saying to you, the things you're exposed to, the stresses that you're having, the things that you're tasting and smelling. All of these different things are leading to real physical changes in the brain in these early parts of life. And there are comparative types of studies that tell us a lot about how it's really essential to have stimulating social environments early on. So rats raised in very stimulating environments with lots of like fun rat toys with other rats, they have much more complex brain tissue than rats that are just kind of raised in an empty box. So you can compare that to things about the development of children. If they have toys and they're be able to interact with other children and their playmates and siblings, then they're going to have richer, more complex experiences, which are in turn seeming to foster this richer, more complex set of connections in their brains. It's also the case that there are pieces of evidence from these rat experiments that they kind of even gain plasticity from this kind of stimulation, social rich environment, because they recover from brain injuries better than the rats raised in kind of the sterile environments. This probably generalizes somewhat to humans. There aren't studies directly looking at this clearly, but it is a real possibility that that plasticity that's fostered by a rich social environment is going to help lead to better being better able to bounce back from injury as well. Okay, now let's talk a little bit about the abilities that are starting early on in life. So when you when you're very young, obviously, you have very little mobility. You're barely able to, even reach out for things, let alone move yourself and do these really complex things. So if you look at the age and months here on the bottom of this graph, we aren't going to go over all this stuff in great detail, but I wanted to give you at least an idea of how this is happening. But really the only movement that is going to happen that much, other than just kind of moving limbs around, is if a baby is lying on the floor, they can lift their head up sometime in the first month, basically. Again, these the kind of black lines in here are kind of the average time this is going to happen. Then the broader orange bars are the range in which it is usually going to happen. So again, there's variability when these things happen, and they might not all happen in this particular order either. But between about 3 to 6 months, you're going to see a lot more movement. That kids might start pushing themselves up on their hands and arms. They might roll over. They might be able to stand up with support, or even sit themselves up onto their behinds with support. And eventually, they're going to get to the point where they are walking on their own, usually sometime between, let's say, 11 and 15 months. There's a lot of variability there. And like I said, these things are the average times, but not all of it is even going to happen. So crawling, for example, is something that is generally going to happen in kids. But for my children, for example, my oldest, my son, and for his cousin, my sister's son, they just kind of skipped crawling. They didn't walk super early. They walked a little bit early, but crawling just didn't really happen for them as much. They sort of army crawled a little bit, but they never were in that phase where they're, going on all fours around the house. So these things, again, are not hard and fast rules. They're general sorts of trends in development. And I think you'll see that happening, see that represented in a lot of the things we'll talk about here, that there are general orders that things happen usually, on average, but it doesn't work that way for every single person. One important idea that's also happening here is that people's development, of course, is starting out, or their ability to move is starting out with their arms, being able to move their head and push themselves up on their arms, gaining more and more core strength and ability to control that, and finally gaining ability to control their legs. So the general order that these things are developing in a motor sense, from controlling things toward the top of your body down, is mimicking the level of neural development and control over our movements overall. Down and out development, meaning down away from your head and out away from your body. So the development is starting at your head and finally ending up toward your legs. Okay, so once people, can walk around their toddler age, they are going to start seeing a lot of other changes in more complex sorts of activities, right? Even up to 2 years old, the hand-eye coordination that people have is very minimal. So after that, you're going to start seeing people being able to throw and catch things much more easily, being able to manipulate objects a lot better, start having more fun with certain types of games because they can actually like do them, right? And the general mental ability that people have from toddlerhood to early adolescence is going to jump up extraordinarily quickly. The difference between a 2-year-old and a 3-year-old in terms of language ability and being able to understand their environment is enormous. And we'll circle back to some of those different developmental things, but I do want to keep going on some physical stuff while we finish up here. So puberty eventually is going to happen as well. It happens a bit earlier for girls usually than boys, but remember I was saying in the early months of prenatal development that testosterone is already starting to be secreted for people with a Y chromosome, and people with certain chromosomes later in life are going to have different secondary sex characteristics that are developing as well. So around 11 years old for girls, 13 for boys, there is going to be a kind of cascade of hormones that's going to have you grow considerably in height and weight and have other kind of secondary characteristics as well, hair growing in different places, and different internal sorts of developments as well as the reaching sexual maturity, being able to actually reproduce. So this is also a good example to just mention all of this because of how your genetic plan basically is telling your body that around a certain age it's right for you to enter puberty. And again, usually around 11 for girls or 13 for boys. But it seems that this is influenced, this genetic plan is influenced by our environments. So when we first started really, keeping track of these things in a very scientific way a couple hundred years ago, people didn't start reaching sexual maturity until around 16 years old. But presumably because things are much safer now, we have much better nutrition and ways to support people, our environments are affecting the way that our genes are expressing themselves. And sexual maturity is being reached, between 3 to 5 years earlier than it used to be. So just to bring back some of the stuff we sort of touched on really quick in the biopsych unit, this is a case of your genes are sort of dependent on the environment you grow up in. Your genes can't express themselves unless they have an environment that supports that expression. And this is true for even enormous life changes and physical changes like puberty. And in case hearing me talk about puberty is not awkward enough, then I might as well remind you that puberty comes from a Latin word that means to grow hairy. So there's that. All right, let's wrap this up, this part up about the physical stuff by talking about reaching adulthood and aging. Your brain reaches its sort of final weight by the time you're about 16 years old. However, you have probably heard that your brain continues to grow and change well into your 20s, and this is true, but a lot of those changes at this point are going to be changes in those glial cells, getting myelin to cover the axons in your neurons to speed up efficiency and speed up transmission. So this is something that is going to continue at least into your 20s. And remember that learning still does occur later in life as well. It just is a little more difficult. So you're still seeing later in life the connections between neurons change. You're not as likely to see new neurons or see additional myelination, but you're going to lose some neurons and you're going to gain and lose different connections. Later in life too, there are, of course, different physical changes that are going to happen. Your body changes quite a bit. Obviously, you have wear and tear over the course of your life, and you have things like aches and pains and wrinkling. Some people shrink a little bit later on in life, and your brain ages too. And there's a stereotype, certainly, that this degeneration later in age leads to people being senile or having dementia. But this, I think, happens much less frequently than people assume. Only about 1% or less of people at age 65, and only about 20% by age 80. So it's not as quite as frequent as people like to say. You hear people say someone has dementia maybe more frequently than it actually happens. But one thing that's kind of encouraging and maybe helps undermine the sort of ageist stereotypes that come out really easily and are kind of some of the stereotypes that we seem to accept more culturally than other ones, that the dendrites of older adults tend to actually be longer and have more complex connections than people in middle age in their 50s. So it seems that our brains are compensating for the fact that we are living longer as a species and needing to have those connections longer. So they are after they're losing neurons, the structures of our dendrites, our neurons, are becoming more complex and making more connections that way to try to stay at somewhat the same level of efficiency. So these different changes, they go on throughout your life. It's not I think in a lot of these developmental sections or courses, there is maybe rightly a very big focus on adolescence and infancy, but development happens throughout the lifespan, which is represented in your class here as well, if you choose to take that one, when you choose to take that one. Okay, so in the next video, I'm going to move on to talk about something a bit different. We'll talk about developing intellectually, and then eventually we'll move on to talk about social and moral development as well.